Physics professor Michio Kaku is one of the world's most recognized scientific experts. He joins us in the studio this morning. Good morning.
Morning.
This is good news, right?
We can almost break out the champagne bottles. The moment of truth is arriving. This weekend will determine almost everything.
All right, let's talk a little bit. We have a wonderful animation setup. This is the mothership, as it were. And what does it drop down into the Gulf of Mexico here?
This is the cap. A lot of hopes rest upon this. We hope to plug up this blowout preventer right here, which is leaking up to 60,000 barrels per day.
All right.
Here's the cap, and these are siphons that also siphon off the oil.
And here's the thing, this thing is like a blowout protector junior, right? It has a lot of the same mechanisms in it, correct?
That's right. There are three valves here, two valves that are open and shut, and the third valve is like a dimmer switch. You can actually adjust it. So a lot of hopes are rising, are resting on this cap.
Right. So this is all the way closed now. So when we look at that picture, we see no oil coming out of here, but what's most important is what's down here. This is what all the testing is about. Tell us what they're trying to test for.
The worst case scenario is that by sealing this up, it puts pressure down here and you can burst a pipe.
Right.
These pipes were damaged by the original explosion 3 months ago. They're damaged. And if one of these things rupture, you could have mini leaks all over the place. That's the nightmare scenario.
The nightmare scenario being if there really is a rupture down here, you could have a crack in the seabed, literally. Well, there were tons and tons of cement poured down into there. It could be leaking all over the place.
That's right.
You could end up with a larger disaster than they have right now.
Irreversible damage. You could be even worse than where you first left off. Remember, the pressure here is enormous, 8,000 pounds per square inch. Take a Mack truck, and put it on every square inch of the pipe. That's the pressure inside.
Man, and it's kind of hard to fathom. Fathom is kind of a good word because you're talking about 5,000 feet below the surface, 8,000 pounds per square inch coming up this way, all this pressure down here, phenomenal low temperatures and difficulties in dealing with all of this stuff, so that they got this done is in its own small way an engineering marvel.
That's right, and we're going to cap the top and choke the bottom. It's going to be a 1-2 punch. That's how we're going to tame this monster.
Right. In the end, though, what they're talking about doing, though, once these tests are done, is opening this up again, having a pipe that will be connected here, and then the oil will all be sent to the surface.
That's right. And realize that this is just a temporary fix.
Right.
The gold standard is the relief wells that are being drilled down there. Ooh. That works almost all the time.
All right. Professor Kaku, thank you very much for joining us this morning. We do appreciate it, and it's nice to have a little good news for a change.
That's right. My pleasure.
All right.